Hello students, today we're going to be talking about exponents. You and I have briefly talked about exponents before in a previous unit where we went over order of operations, but today we're going to go ahead and take a deep dive into exponents and how to solve them and what they mean. So to start at the very base level, I want you to look at Model A. And our directions say represent the area of each model in mathematical terms. So, in order to represent the model that's Model A, we need to figure out exactly how many dots are being represented, right? So going across here, we have 4 dots. And going down, we also have 4 dots. So that means that we have 4 rows of 4. So that would be a 4 times 4, which would give us a total of 16 dots in this model. This is similar to what exponents are. When we are taking a number and multiplying it by itself several times, that is the math behind exponents. Now in Model B, we've got the same thing. Going across, we have 3 triangles. Going down, we have 3 triangles, which means we have 3 rows of 3 triangles. So that is 3 times 3, which gives us a total of 9 triangles. Same concept, we're multiplying a number by itself, giving us a total of 9. And finally, for Model C, I have 5 going across, 5 going down, which would give us a total of 25, because I know 5 times 5 is 25. And that would be the area of each model in mathematical terms. Now, let's go ahead and give us some vocab and some context to these exponents. Filling in our notes down here talks about the base. The base is the number being multiplied by itself. So in this space here, I want you to write multiplied. Okay, our base number, when looking at these models up here, our base number would be this number right here. Okay, it's the number that's being multiplied by itself. So when we're working with exponents, this big number right here is the base. 9 is our base. Not the little 2, but the big number 9. For this example, for this expression, 6 to the 4th power, 6 would be our base. Since it's the bigger number, it's the big number, the main number in this problem. The little 4 would be our exponent. So for our exponents, the exponent determines the number of times our base number is multiplied by itself. Let's go ahead and write itself here. This cute little number in this expression, that 2, tells me, that's my exponent, tells me how many times my base, 9, will be multiplied by itself. So for this example, 3 to the 5th power, 5 is going to be my exponent. In this example, 2 to the 7th power, 7 is my exponent. It's telling me how many times I'm going to multiply 2 by itself. Any number raised to the 2nd power is said to be squared. So if you're taking a number, say you've got 3 to the 2nd power, your base number is 3, and 2 is your exponent, you're squaring 3. Okay? Any number raised to the 3rd power is said to be cubed. So you're going to hear this vocab a lot as we're working with exponents. If you have 4 to the 3rd power, it's cubed. Okay? Now, if you don't totally grasp that concept right now, that's okay. You're going to be hearing that vocab quite a lot as we work through these problems here. So, farther down on the page, it says use each term below to determine the base and the exponent. We're going to fly through this really quick based off of the notes that we just took. So, for this expression, 3 to the 4th power, my base is 3, and my exponent is 4, because 3 is the big number, and 4 is the little number. So therefore, it's my exponent. 7 cubed, or 7 to the 3rd power, my base number has to be 7, and my exponent has to be 3. because 7 is the big number, and my little number is my exponent, which is 3. For this expression, 9 squared, or 9 to the second power, my base is 9, and my exponent is 2. For this expression, 8 to the 9th power, or 8 times itself, 9 times, my base would be 8, and my exponent is 9. Now for this expression right here, that is 12 raised to the 0 power, which is 12, as my base, and my exponent is 0. Now I know that that problem looks kind of crazy, 12 raised to the 0 power, but all this is any number that has an expression like this that has a base of a number that's not 0 means that this would be equal to 1. So 6 raised to the 0 power would be 1. 2 raised to the 0 power would equal 1. But anything that's 0 raised to the 0 power, now that would equal 0. Okay? Again, not super important if you're not totally understanding what a number raised to the 0 power would equal, but just know that if any base number that's not equal to 0 has an exponent that is 0, your answer is going to be 1. Okay? Moving right along, we're going to complete the missing values in the tables below. We're going to skip a couple of these, so we're not going to fill out all of them. But again, we're just working with terms in regards to our bases and our exponents. If my base is 5 and my exponent is 3, then my term has to be 5 cubed, or 5 to the 3rd power. In this term, I have 19 as my base number, and my exponent is 2. For this term, I've got 16 raised to the 4th power, so my base would be 16, and my cute little 4 here is going to be my exponent, telling me that I'm going to multiply 16 by itself 4 times. For this one right here, I've got a base of 7 and an exponent of 6, which means that my 7 is going to be the big number, and my exponent is going to be a little 6. Go ahead and flip your notes page over for me. On the next page, we're talking about the difference between expanded form and standard form. Okay? Expanded form shows the full multiplication of the base. So this is getting into solving exponents now. So if you have an expression or a term that says 6 cubed, 6 to the 3rd power, that is written as 6 times 6 times 6. You're taking your base number and multiplying it by itself this many times, 3 times in a row. If you have 3 raised to the 6th power, that would be 3 times 3 times 3 times 3 times 3 times 3. Okay? And you would just solve both of these working straight across. Okay? So this would be 6 times 6, which we know is 36, and then you would take 36 and multiply it again by 6 to get your answer, to figure out what that is equal to. Now, standard form, when a number is raised to a power, or when the number is simplified, then it is called the standard form. Okay, so whenever we are solving our problem, whatever your answer is to your exponent problem, that is standard form. Okay, that's your answer. This is equal to your answer. So we're just going to do a couple of these now. This is complete the missing values in the table below. If this is my expanded form, 5 times 5 times 5, then that means that I have 5 to the 3rd power, or 5 cubed, okay? My standard form is going to be my answer. So I know 5 times 5 is 25, and then I need to take my 25 and multiply it again by that 5. 25 times 5, I know, is 125. So my standard form would be 125. That's my answer. Now, I'm going to go ahead and skip down to 7 to the 3rd power, or 7 cubed. That would be 7 times 7 times 7 in expanded form. If I do that math, I know that 7 times 7 is 49. And then I need to multiply 49 by my last 7 here. 49 times 7 is going to be a big number. It's going to be 343, okay? And that would be my standard form. That would be my answer. I'm going to slide on down to 3 to the 4th power. So 3 times 3 times 3 times 3. My base number I know is 3 because that's what I'm multiplying over and over and over again. And I'm multiplying that base by itself 4 times. 1, 2, 3, 4. So that means my exponent has to be 4. Now I'm going to go ahead and solve this. 3 times 3 I know is 9. Then I need to take that 9 and multiply it by this 3 right here. I know 9 times 3 is 27. And then I'm going to multiply it by my last 3. 27 times 3 is 81. So therefore 3 to the 4th power would be 81. And 81 is my standard form. Okay, I'm going to ask y'all to go ahead and just skip this bottom portion right here. If you got a couple minutes before this, before we switch to our next rotation, go ahead and try and some of the problems that we didn't do together in this box here. So try and figure out what 9 to the 1st power is, or 4 to the 3rd power. Okay, best of luck to you. Good job.